Hello, my name is Xander. Welcome back to another Python Beginners course tutorial. Here we're going to look at collections of data. So we're going to be discussing tuples or tuples, lists and dictionaries. This is the 7th module of the Python Beginners course. So by all means, utilize the video description. You'll find a link to the previous tutorials. What I see in other courses is that they tend to introduce lists and dictionaries when you start to learn a little bit about loops. So that can be a good approach, but I think that, and what I've tried to do here in this module, is just give you the basics of working with tuples, lists, and dictionaries. And this should give you a nice background, a good context, and a reference point, so that when we do move on to more complicated material, we'll be able to look back and review and just remind ourselves utilizing the simple examples I'm going to show you. Python provides us 4 collection data types: a list, a tuple, or a tuple. It's up to you how you want to pronounce that. Dictionaries and set. In this tutorial, we're going to cover tuples, tuples, list, and dictionaries. So let's first take a look at tuples. So I'll start by just introducing basics, and then we'll fill in the gaps and establish what it is tuple in this case is. So a tuple or tuple is a collection that is written in round brackets, it's ordered, it's immutable, so it cannot be changed once it's set, and then the items are indexed. So there's a lot going on here. So by the end of our conversation, or our look at tuples or tuples, hopefully we're going to understand a little bit more about this. So let me just take you back to the module, the strings module, where we looked at this idea of indexing. So the string was, if you like, index, and we could refer to each letter in the word by this index reference point here, 0, 1, 2, 3, and 4. So we're going to take those principles here. And now when we create, in this case, a tuple, so if you remember a tuple, we had the brackets, inside of brackets. Now we will have commas here. You'll see that syntax shortly. But each item in this tuple is index. So if we wanted to reference and to print out rock, that would be 0, 1, 2, 3, 4, and so on. So we can say here that the tuple is indexed. Now we're saying this is immutable. So once we've defined a tuple here, we cannot change it. So unlike what we see lists and dictionaries where we can change and add and delete, here with a tuple, we cannot do that. So once we've set, here we're saying it's immutable, so it cannot be changed. So we're back in Visual Studio Code. I've got my example.py file. So let's go through some examples of utilizing tuples or tuples. Right, so let's start off by building a tuple. So I will say item or items equals. So we're going to create a tuple. So this needs to be in the parentheses here. And here we're going to define rock, paper, and scissors. So again, we're using a string. So we've got the doubles here, paper, and then scissors. Okay. So this is a tuple that stores data. Here we can change, of course, so we can store multiple types of data, like we can do in all the dictionaries. So we can store numbers, and that can be float or decimal or integers, or we could potentially store true or false, for example. So let's just give this a go. So let's just go for one of each. So if I want to now print this out, let's give this a go. So I referred to it as item, the variable. Let's just go ahead and print this out. And there we go. So we can see instantly that we can store this tuple, this collection of data, inside of our variable, and we can print out our tuple of data. Right, but of course we might want to select, or we will want to select, individual pieces of data. So how might we do that? So just going back here to this idea of this indexed idea. So if we wanted to select the first item, it's referred to as 0 or index as 0. So let's go ahead and try and do that. So now what we can do is use the square brackets here. And so inside of our tuple here, we want to access 0, the first item. So let's go ahead and we can do that. And there we go. So that's going to be the same, of course, for 1. And then if I change this to 2, and of course, we're going to receive an error if we select an item that doesn't exist. There we go. So we're in indexed error. So that's worth noting and remembering. So an index error. So it does clearly identify here that the tuple index is out of range, which of course is suggesting that item 3 does not exist. So alternatively, if we wanted to select items, we could use index. So let's use index, and then in our index we've got, for example, let's try 1. Okay, so that was interesting. So I've typed in index, item.index 1, and it's returned 0. What happens if I type in 2? You can see it says value error. So this value is not in this tuple. So let's just continue a second. Let's just go ahead and select true. Give that a go. You can see that's also placed or is returning 0. So it's definitely worth thinking what's going on here. Now, you might be confused. So let me just change true to, for example, false. Let's go back now and type in 1 again. Let's see what happens now. So notice that we're returning the index of 1. So what we're doing here is we're printing out currently where in the index this item exists. So here I've typed in 1. So this is now in position 0, 1. So we return 1 there. But notice that when I add true here and leave it a 1, we get position 0. And of course, we also know that true is also position 0. So that's an interesting point to make. And I wonder if you can work out why that is. So if you remember back when we were discussing Booleans, we knew that true also represents 1. So in this case, when we do type in 1 here, in actual fact, it's looking for the first instance of 1, and it's at index 0 and not index 1. Of course, you saw that when I change this to false, for example, you can see that the index is 1. So index position 1 here, and not index position 0. If I were to change this to a 0, that would then give me position 0, because false also represents 0. So we can do all the same thing here. Scissors, for example, that should give me position 2. There we go. So I can use index here to find the position of items in my tuple or tuple. Okay, so that was a bit of a curveball. Yeah, I wasn't actually going to show you that, but it just presented itself, and it was quite an interesting point to make. So we can identify utilizing index where the particular item is in our tuple in terms of the index, so we return the index value of our item. Okay, so we've seen that we can utilize multiple data types within our tuple or tuple, and we've seen how we can then access them individually. So utilizing the index, so here index 0, here is false. So index 1, so that's referring to this item here, index position 1, and we saw index position 2, scissors. Right, so let's now move on slightly and now have a look at just maybe if we wanted to add one item. Let's just go for one item inside of our tuple. Okay, so there's a few rules here that we need to consider. And the first one here is the fact that if I change this, for example, we're going to receive the same error, is that we have to have, we don't have to, we can utilize one item in our tuple, but if we do, we need to use the comma. Okay, so once we do that, you can see it's going to work okay. So just be careful there. If you do accidentally, or you do happen to only store one item in a tuple, just make sure that there is a comma. Okay, so going back to some of these rules that we saw earlier, immutable cannot be changed. Right, so let's try and see and give you an indication or an example of this. So what we can do here, we can select an item in our tuple. So you might be able to imagine, well, if we can do that, we can potentially go ahead and then change it, for example. So for example, if I said now item now equals, for example, let's give this a go. So let's change item in position 0. So we're going to get the item in position 0, which we know is the integer 1. And now we're going to change that to equal 2, for example. So let's see if we can do that. So you can see here, tuple object does not support item assignment. So we can't go ahead like we can do in, for example, a list and change an item. in the list in this manner. You can see the terminology here, item assignment. So it does not support item assignment. So here we're just suggesting and why we're saying that the tuple is immutable. We can't utilize item assignment to then replace the item. So what we can do, of course, is we could copy. So now item equals, for example, 2. So we can make a copy. So there we go. So now our tuple equals 2. So we've just basically overridden it in that respects. But we can't individually select items in our tuple and change them easily. Okay, so we got some basics of a tuple there. And now what we can do, and this is a bit contradictory to what I said at the start in terms of loops, let's create a loop. So what we're going to do here is just loop through each item and print it out. So although we are going to cover this in the next module, I just wanted to introduce it very briefly here. So we're going to use a for loop and we're going to get, for example, item. So for item and then in item. So what we're going to do here is we're going to get the item which is holding the tuple, and then for each of item that's inside of our tuple here, so this probably should be X. Let me just change this to X. All right. So for X in item. So this is just suggesting, or this is essentially saying, if I was reading this, get the tuple, all the data, and then for each item inside of this tuple, we're going to loop through and do something with those individual items. So what we're creating here is a loop. We're going to loop through item for every time it finds a piece of data inside of our tuple. And every iteration, so for every loop, that data, so we loop through once, and our data 1 is going to go into X, and we can print X out. Then it's going to find 2, it's going to put it into X, and then we can print out X, print out number 2, and so on. So this is our loop here. Right, so what we're going to do with our loop is we're just going to print, and in this case, we're just going to print X, right? So what we've done now is, like what I've said, we've created a loop. So for every piece of data inside of every piece of data here inside of our tuple, it's just going to loop them out. And we referred to it as X, each item. So let's give this a go. And there we go, 1, 2, 3. So don't worry if that doesn't make sense. We're going to explain that in a little bit more detail, a little bit more graphics for us in the next module. But you can see we can print out a tuple, and that was the main point here. So what we could do now, for example, is just go for an example. Let's just have 1 and 2. So let's print item, just to finish this off. So we're going to print out the original tuple there, and let's now go for let's loop this out for X in item. Let's just go ahead and just practice this, printing this out. So we're going to print out X. So that's going to print out the original data. So remember what we utilized earlier. We could say that we could reassign our tuple. So now our item equals 2 and 3, for example. So we can't directly overwrite, but we can definitely, or can't use item assignment, but we can definitely recreate the variable here and reassign the tuple data. So let's now just print all that out. So we can do the same thing again. There we go. So let me just see that in action. So here we printed out 1, 2, and then 2 and 3. So that should be 3 and 4 to give you a better idea. There we go. So we've got 1, 2, and 3 and 4. So hopefully now we've got a general handle of how to utilize tuples or tuples. So as we move through the course, we'll get to look at and utilize tuples or tuples in the next modules. So we'll try and incorporate them into the next modules to keep us refreshed and refresh our memory of some of those aspects of a tuple. But it's important to understand, just going back here, of the parameters or the attributes, sorry, of a tuple, because here you're going to make a choice in your program. You're going to decide whether you want to use a tuple, whether you want to use a list or a dictionary, and they all have different attributes. And depending on what you need in your program, you may choose or utilize different collection types. Okay, so now let's move on to lists, which are probably the most popular data collection type that you'll probably be utilizing. Now, there is a whole host of different features or functions that we can utilize here in this, and I'm going to just take you through the basic set, but by all means read further, and once you feel comfortable with what I show you, you'll be able to easily introduce the other functionality that you can perform on a list. So let's have a look at a list. So let's start by looking at the list qualities or attributes here. So a list is a collection of data that is written in square brackets. So that's one of the main differences here in the difference here between a tuple and a list. We're using square brackets here where we're using the parentheses before. Now this is an ordered list. It's changeable in comparison to our tuple, and the list items like the tuple are indexed. So we can access and change items within our list utilizing the index assignment. Okay, so we can see here that we have a similar setup to the tuples here, rock, paper, scissors. So again, like the tuples, we can use a range of data, whether that be numbers, floats, or booleans, for example. So we have that ability to utilize in our list those different data types. So here you can see, like the tuple, we can, first of all, we're going to print out the list. So we're going to see that. And this time we're going to then utilize the index, so 0, 1, and 2, just to output the individual items. And then we can, in addition to that, we can also utilize index to then select the item index point. So let's go ahead and do that. You can see here that we've selected rock at the end here. So we have index 0. So we've identified where in our list rock is included in our list. So that's the basics. Again, very similar to the tuple. So just to prove the point, let's just go through the motions. So just to prove we can use different data types here, we can do the same thing here, and we're going to cause an error here. So value error. Okay, so it's always good to see the errors so we can become familiar with them. So again, this is a fairly simple one to resolve, value error. It clearly identifies after that that rock is not in the list, which is obviously indicating that we're trying to access something that isn't in the list. So that's a simple one to resolve. Right, so let's just go ahead and change that to, for example, 1. Okay, so you can clearly see that we're utilizing different data types. So the chances are at some point you want to measure or you want to check the length of your list, so the amount of items that are inside of your list. So this is a pretty simple action to perform. Here we're going to use len, and then all we then need to do is just bring in the list here. So that's going to give me the length. In this case, it's going to be 3. So don't forget, all this code is in GitHub. We're just going through it one by one, familiarizing ourselves. Now, you may prefer just to go to GitHub and have a look at the code and just have a look yourself and go through. By all means, do that. And that's not a problem, of course. So this is a reference point. So also don't worry about if you can't remember all of this, okay? Just try and give it a go. Once you've done this a few times, it'll start to appear, or you'll start to retain the information in your brain, of course, but this could take months potentially of you continually doing this. Like anything, of course, repetition is going to be king here, and that's why you should try and always follow tutorials or just practice whenever you get a bit of time. And you could utilize the code in the repository, maybe just spend a little bit of time each day just going through and typing it out every day until eventually it's committed to memory. Okay, so we've got the length of a list. What about if we wanted to actually build our own list? How would we do that? So here we have a constructor, the list constructor. So we can do the same thing, of course, with, and I didn't show you this, with a tuple. But let's go ahead now and just build a list and put it into a variable. So it's slightly different here. So all we need to do here is create a list, and then don't forget the we're going to need a double. Let's get this right. So we're going to need double brackets here, So let's go ahead, and we built this list. Basically, we're doing the same thing. We're storing it in item list, and now we're just going to print it out. So it's got a length of 3. Let's go ahead and just print this out. Now, how do we know it's a list? Well, we can see here, we can see the square brackets here, right? But how else could we find out what type of data structure we're using here? So we do have the ability to do that. So let's go ahead and use type. So here we're going to work out the type. So let's give that a go, and you can see here we're utilizing a list. Okay, so a lot of things I'm showing you on lists that I didn't do or didn't perform on the tuple, they can also be performed on the tuple, and we'll find later it's a very similar setup on the dictionary. So here we have 3 items here in our list. So next thing to start to understand, which can be a little bit more complicated to begin with, we have introduced this before when we spoke about numbers previously in the previous module, is the idea of kind of slicing and selecting a range of data. So let's just change this, for example. Let's just put some more numbers in here. So we do have the ability to not only select individual items like we've done previously, but we can also select a range. Again, if you've forgotten or if you're not too familiar with that idea. So here we're going to get the list, and now we're going to use the square bracket. So we're going to select a range. So 1 to 2. So just have a think for a second. What numbers do you think are going to appear here? 1 and 2. So remember, these are index 0, 1, 2, 3, and 4 in the background. So that's going to produce 2. So remember, index start 1. That's position 1. And we're going to finish at 2. Remember, that's just before in this case. So we're not going to show this one. 2 here is referring to stop here. So we're basically starting here with 1, and then we're going to stop here at 2. So obviously we change this to 3. That's going to then show us numbers 2 and 3, because here we're telling Python to stop here at position 3, 0, 1, 2, 3. So slicing, so we can select a range of items. Now, if you go back, or if you just remember, we've got negative as well, so we can perform and go from the end instead of the start. So if we just wanted the first item, of course, we could do that. And then, of course, we've got multiple different ways of slicing and selecting from the range of data here. So it's worth just reminding yourself of that. I won't go through each one again, but go back to the module. I think it was the math module where we went through the different slicing. So particularly if you are interested in moving into data science, this will be an important aspect for you to learn in actual fact. So it's well worth recapping and just spending a bit of time making some notes, or just copying the code from the previous tutorial where we kind of moved across that, and or exploring that a little bit further, utilizing other sources online. So we can start to kind of move this into other areas here. So we can move this into an if statement. So if one is in, so here we can use in item list. So we're going to check to see if 1 exists in our list. Then we're going to print, let's just print yes if it's inside. So if 1 is found inside of our list, we're going to print yes. There we go. So it's in our list. So let's just go for the number 5, and then let's just go for number 6. So 6 won't be in the list, so we won't receive anything at all. There we go. Great. Okay, so we've talked a little bit about slicing, selecting a range of items, and you can see that we can utilize it in our if kind of conditional statement. So now let's think about actually changing our list. So we saw that the tuple was immutable. So let's try and perform the same action as we tried on the tuple with our list here. So that was basically just taking our existing list, and what we tried to do here was to select an item that we wanted to change. So let's go from position 0. So I want to change the number 1, and I want to change that number to 10, for example. So let's just see if this works. So it should work. So the list is not immutable. So there we go. So you can see that I can select different items or different by the index here and change. Okay, so now we know how to change a single item in our list. Let's think about now maybe removing. So at this point, we'll find that there's a whole range of different functions we can now perform on a list. And it's well worth just going through some of the basic functions here. But like I previously mentioned, there are plenty more that I won't be able to cover here. So let's just go for remove. So we know that we have the number 1. So let's just go ahead and remove it. So it says here, the list object attribute remove is read only. Okay. So I kind of given you the answer secretly there, or covertly, in that remove is a function. So a function, we need to pass something into this function, in this case a value, that we want to remove. So we want to remove the number 1. So let's go ahead and do that. And there we go. Of course, that's going to work in the same way as if we had some sort of string. We're going to need to pass that in as a string. We can then go ahead and remove that. We could, of course, we could buddy this up with, for example, an input. So let's go ahead and do that. So here, for example, we could have an input remove. So we could ask the user to select an item, say, for example, number 2. And you can see that's not in the list here. So you may have worked out why that potentially isn't working. Take a second. So here I'm trying to remove 2. So I have an input, type in 2, and now we have value error. But we can clearly see that 2 is in the list. So there must be something wrong. So let's just go ahead and try and change that into an integer. Let's just give that a go. 1, and there we go. So if you're not too familiar, this was in the, I think, the first tutorial where we're looking at casting different data. So what we've done here is we've changed our input, which we know is a string, into an integer. And now we're working for an integer, of course, in our list. And therefore we can then remove it. So we've been slowly learning more about how to manipulate our list here. So let's just go through again. Let's just add an item to this list. Now, if we just, there's 2 tools here. We have, for example, append. So item underscore list. Now we can utilize append. So here with append function, this is going to add to the end of a list, like it says here. So let's just add the number 6, and we go ahead and print out our item list again. So that's going to add to the end of our list, and that's always going to be the case. Now, there are times where you don't want to do that. So maybe you want to add to the start of the list, for example, or somewhere in the middle. So what we have here is just a different tool for this. So let's go ahead and now insert. So we have append, which is going to append, add an object to the end of a list. And here we also now have insert, which is kind of a word which is suggesting that we can insert somewhere into our list here. So there's 2 parameters here. So first of all, you can see here, we've got index, the index, and then the object. So we need to define where we want to add a new object. So at the start, position 0. And then what we want to add. So this, I'm going to add the value 0. So it's going to say 0, 1, 2, 3, 4, 5. So let's give that a go. And there we go. So we now have 0, 1, 2, 3, 4, 5. Right, so 2 tools, insert and append. Right, so what we can also do, like we've done previously, let's just go for that. So 4x. So we'll just loop round and we'll just loop everything out. And I'm just doing this as a repetition type of activity. So we kind of start to familiarize ourselves with the for loop or the syntax of it, so that in the next module, it becomes a little bit easier to utilize. So let's just go ahead and print. That's going to be X, of course. So all the items in our list, one by one, is going to loop through and print out. And every time it loops, the item's going to go into X. And then we're going to utilize X to reference it so we can print it out. So there we go, 0, 1, 2, 3, 4, 5. So that's our loop. So we can see that we can loop out our list. Now we can also sort. So it might be that these numbers here in our list, they are out of order. And again, this is more of a kind of data science type of activity. Potentially here, you want to order our list, or you want to maybe perform some more actions on the list, and ordering it is obviously very important. So here we're just going to use sorted. So let's just go print and then sorted. And then here we've got what do we want to sort? Item list. So that's going to sort the order for us. There we go. 1, 1, 3, 4, 5. So let me just change that to 2. There we go. Right. So if I were to use, for example, letters, what's going to happen here? Obviously, I need the double quotes, but just to point this out and you can have a go, this is just going to put it in alphabetical order if you've got strings. So it's going to work on strings or numbers. So again, I do appreciate there's a lot there to learn, and it's just a case of practicing. Just keep writing it out. Eventually it'll start to seep in and you'll start to memorize some of this code, as well as possibly just keep practicing. Of course, if you don't use it, you'll definitely lose it. So let's go have a look at the list qualities again. So it's written in square brackets. We've seen that. It's changeable. We've seen that. Add, delete, insert, append. And then the list items are indexed, so we're able to access our items from our index or the position. Now, this idea of ordered, this is something that I've not explained. So it's ordered. So that doesn't mean that we can order things. This is suggesting here that when the items are in this list, this is the order. So we always know that this integer 1 is going to be in position 0. The 4 is going to be in position 1, and so on. So when we say this is an ordered data type or a collection, it means that we've got this consistent order. So anytime we print this out, it's going to be in that order. So it's an ordered collection type. So that's the same as a tuple. So it's ordered. So on to our final collection data type, dictionaries. Let's take a look. So here, this is slightly different. So a dictionary is a collection of data that is written with curly braces. So here we've got a different way of creating a collection type. So we've had the parentheses and the square brackets. Now we're using curly braces. So this time we actually have a key value pairing, and we'll see that in an example. So here it says an ordered collection. So a dictionary is an ordered collection. Now, prior Python 3.6 or 7, this wasn't the case. So we've learned that an ordered collection means loosely that if the data is in position 0, then it's always going to be in position 0. Obviously, unless we override it, but that's always going to be the case. It's always going to be in the same order as we've defined it originally, unless we change it, of course. So here, what's interesting is that our list allowed us to use duplicate values, but here in a dictionary, that's not going to be the case. So we'll take a look at that and see if that is true. So a lot of the principles here that we've already covered are the same for a dictionary as they are with a list and a tuple. So if I wanted to find the type, I could. If I wanted to access it, I can do this in a similar way, utilizing the index position. So we can see here how this is set up. So our dictionary here has the curly braces. Now it has what we describe here as a key value. So we've got a key 1, a value rock, key 2, paper. So these keys can be numbers. These keys could be a string, a random string. So there's no ordering here if you're thinking about 0, 1, 2, 3, 4, etc. here with these numbers. This is just something that I've made up for now. So we could definitely utilize a key as a string, or in this case, an integer. So let's see the behavior here. So we're going to print out the type, which is going to be a dictionary. Then we're going to go for type here, and we can actually then select individual items in our dictionary here and see the type of data that we're storing. So this is going to be a string. So position 1, paper. So here we're then going to go ahead and try and print out index 1 and index 2. So let's have a look. So here we've got class. This is a dictionary. So it's identified that this is a dictionary stored in this variable. And then this is a string, which is true. So position 1, 0, 1. Okay, and then we've then gone ahead and then selected. Now notice here, we're selecting by this time our key, which is 1, so not the indexed. So that's an interesting point to make. So here, for example, if I typed in 0, so let's just bring everything back out here. So here's before we were selecting via the indexed. Remember we said this was kind of indexed, so 0, this would be 2, and this would be 3. In this case, it doesn't seem to be the case here. So with the dictionary, when I type in 0, there is no index 0 here. So I'm referring to the item via the key. So 1 equals the data in the key that's referenced in this data here is rock. So if I change this to this, for example, so let's just see if those principles are true. So I'm going to reference the data via a string here, and it's the case, still the same case. So here we have key value, and that's important to understand here when you're utilizing dictionaries. So again, the dictionary is not immutable, so I can change values here, but all I just need to remember is that here I'm not selecting the index, I'm selecting the key that I want to change. So here, for example, let's just go ahead and change something here. So we're going for item dictionary, and then we're going to select via the key the first item, which is going to be rock, and then we're just going to change it. So like we've done previously, let's just now change that to sock, for example. So when I print out, we now have the value sock. Okay, so we can go ahead and update. So similar operations again, slightly different from our list. So let's go ahead now and just utilize update. So dot update as a function, and then we want to now add some data or some new data. So let's just go for 4, which is then going to be shoe, and then we can add more. So utilizing comma here, we can go for another item, so key values, shoe, and then sock, for example. So let's just give that a go, and there we go. So we've added some more data here in 4 and 6. That should probably be 5. There we go. So we can view data, we can now update data. So let's go ahead and delete. So here we're going to utilize pop. So let's just do that. So if I want to delete something, let's just go ahead and utilize pop. So all I need to do here is just select what I want to remove, for example. So 1, and let's just go for none. And then let's have a look. And there we go. So we've now removed the first item. So now we've done the most of CRUD really, update, add, delete, or part of the kind of CRUD, which is an acronym for create, return, update, and delete. So we have pretty much done that here. So you can now see how to update and delete items within the dictionary, add to the end of a dictionary using update, for example. So you can see that the principles are the same, and what you need to learn, or the basics here, are the same for each. Obviously the tuple is immutable, so we can't add data there, but with the list and with the dictionary, we want to kind of try and memorize update, add, update, delete, and selecting data, arrange, slicing data, for example. So that really pretty much covers the basics here that I want to show you, utilizing these collection data types. So like I keep saying, apologies for repeating myself, just utilize this now as a reference point so that we move on to the next section, and onwards we can utilize this and just refer back to it. So let's go for a code challenge. There's only one here, but let's have a look. So in the previous module, we built a rock, paper, scissors game, right? So let's first replace the list used to store the values rock, paper, and scissors with a dictionary. So if you remember, if you saw the previous module, we asked the user to select or input rock, paper, or scissors, and they actually had to type that in. So what I want you to try and do now is remove that and replace it. So we're going to ask the user to select 1, 2, or 3. So 1 being paper, 1 being rock, 2 being paper, and 3 being scissors. So they don't have to keep typing in the words when they start the game. So the rest of the game is going to be exactly the same. So there's probably no changes there we're going to need to make. So the changes, first change is we're going to change from, I think, a list to a dictionary. And then we're going to ask the user to select 1, 2, or 3 to input or to select their option of rock, paper, or scissors. Now, this is a kind of a trick question. And there's something that I've not shown you here that you're probably going to need to utilize. Now, you will get this partially working potentially, or some of you may have issues if you were to follow what I've shown you so far. So this is a little bit of troubleshooting as well. If you do have a problem, this particular problem that we're going to receive here, and that's, let me just give you kind of a hint here. That's because we're not using a list. Now, remember with a list, when we select a random item, we can just select from the index 0, 1, or 2. That's rock, paper, or scissors. Now, remember here that we don't have that set up because we're using key values. So when we perform random, we need to try and work out a way of selecting from the key and not from what would originally be the index. So that's going to be the real interesting point. Now, you will find that it will potentially work, but you might find with different values it won't work and it'd be really inconsistent. So that's the biggest challenge here. And obviously I'm going to show you the result or the solution, but by all means have a go at that first and then we'll go through the solution. So let's take a look at the solution. So I've copied and pasted across from the previous tutorial the rock, paper, and scissors game that we set up. So here we're utilizing a list here, and we want to first of all convert that. Well, let's just make sure this is working actually. We may as well. So let's just go ahead and see if we can do this. So at the moment we need to type in rock, paper, and scissors. Yep. So this is working okay. So let's go ahead now and just convert this. So the first thing we need to do is let's just go ahead and change this into a dictionary. So that's going to be a case of using key values. So I'll just go ahead and change it like this, 2 and 3. Right, so that's my dictionary that I've created now. So I've converted that. So this time we're going to ask them to type in the number. So that might not make perfect sense to them, but let's just add a number there. So 1, 2, and 3. So the user is going to type in 1, 2, or 3 to select rock, paper, or scissors. Right, so we've got that in. So now we need to think about what we're doing here because we're using integers now. So we've got this random choice. At the moment, random choice from our item list. So that's a random choice. So let's go ahead and further down here. That's going to select the random choice. Fine. And that's going to print out the random choice. If choice. So that's the user input. So at the moment, that's going to be a string. And what we're doing here is we're typing in numbers. So maybe what we need to do initially is just convert that into an integer so that we can compare it against an integer. I guess what we're trying to do is that, for example. So that doesn't quite make sense potentially, but let's just give that a go, see if that works. So 1, okay, you did not enter a valid option. 2, so we seem to get the same problem here. So we need to remember that what we're trying to do is select from either a key or the value. So here with a dictionary, we can select 3 things essentially. We could select, for example, the key, we could select the value, or we could select the whole lot. So let's go ahead and have a look at this solution here. So let's just start off by just converting or casting the user's input, because we know that's going to be an integer, right? So, or we want to cast that into an integer. So we know that that's going to be an integer, right? So now working with an integer, we want to match these integers to our keys here. Right, so now we know that. Let's now update our random choice. Now remember this random choice, what that is the computer making a random choice so we can play the game, so we can compare our choice to the computer's choice, and then we can work out whether we've drawn or we've lost or we've won. So if you don't know rock, paper, and scissors game, I do apologize. I'm just assuming that you do understand the principles of this game. So let's just start off by changing the user's input here. So we know that's going to be, or we want that to be an integer, right? So let's go ahead and do that. Right, so that's now an integer. So we're saving that as an integer, right? So that's that done. So we import random, fine. We've created our list of items, which is a dictionary, and now we've got the user's choice. So that's that done. Right, so now let's get our random choice. So I'm just going to put an underscore here, random choice. Right, so we're going to get the computer to select a random choice from our list. Now, what we're going to do here, in order to get a random choice, is we're going to collect the data in our dictionary and we're going to build a new list. So let's go ahead and use the list constructor here to build a new list. We're going to go into our existing, or select where our dictionary is, and then we're going to select the values, the dot values. So we're going to get the values from our dictionary, all of them. We're going to iterate over, get our values, and then we're going to store it in our new list. Okay, so that's our list, and then what we can do is we can just select a random item from that list. Okay, so working backwards, we're going to get the values from our dictionary, turn that into a list, and then we're going to then create a random choice from it. So what we have now is the random choice. So that's going to be rock. Remember, that's going to be a string, rock, paper, or scissors. Okay, so we've got that in place now. Right, so what we could also do while we're here talking about this is selecting the value. So that's the value. Now remember, this is the key and this is the item. So we can select all three. So by changing this variable here, we've got key. So if I wanted to select the keys, or if I wanted to select, for example, the items, I could do that right there. Okay, so what we want here is the value. So we've got values. So that's that in place. Right, so let's go ahead now and just print out that so we know what the random choice is. Okay, so that's the computer's random choice, so we can just see what the computer random choice is. Right, so now we've got that in place. Let's now build the rest here. So if integer choice, right. So let's now change this to item list, right? So if item list, so let's do this item underscore list, right? And then we're going to take in choice. Now remember what's happening here is that we're taking the user's choice, which is 1, 2, or 3. So what we're going to do is going to select from our dictionary via the key 1, 2, or 3. So what's going to return here is going to be the value of 1, 2, or 3, which is rock, paper, or scissors. So we're now going to use this. We're going to compare, aren't we? Or evaluate this. So does, for example, if I type in 1 rock, does it equal rock? If it does, we're going to move on and so on. So that's how we're going to get the user's choice and run that. So we can do the same thing here and just copy this down where our choices are. So that's how we're going to get the user's choice and compare here in our conditional statement. All right, so we know that the random choice is whatever the computer's selected. So let's just change and update this code with the underscore. That's what the computer has chosen. So we did talk about in the previous tutorial how we could streamline this code a little bit. This is very fleshed out, this piece of code, just to kind of take you through it step by step if you're not familiar with if else statements. So by all means, you may have kind of refactored this code slightly. Right, so that's that done. And I think we're done. So let's just give this a go. So number 1 is rock. So the CPU choice or the computer choice was scissors. Rock beats scissors, so you win. Cool. Right, let's try number 2, paper. So the PC also chose paper. So it's a draw. And then the last one, 3, I chose scissors. CPU chose paper, and therefore I win. Okay, so those are the modifications we've made. Hopefully that was fairly useful, or you understand what's going on here. It's always interesting to get your feedback because I could talk all day, but if if I'm not being structured, if it's not logical, if you aren't understanding it, there's no point, of course. So it's always good to get your feedback if you want me to be a bit slower, if you wanted more examples, if you felt the examples were too easy. Anything like that is always valuable to identify and understand how some of you are thinking or feeling going through some of these examples. Okay, so that was the solution for code challenge 1, or potentially one solution, because there are many solutions here that you could utilize. Now you need to remember that we are using Python 3.9 here, and I've already identified to you some of the potential changes that you might see on different versions. So if you are using an older version of Python, that code may have not worked at all. So it's important to understand what current version you're utilizing and trying to keep up to date if you can when new versions of Python do get released. Just have a look at what some of the updates are, because your code may start to be it may need to be updated slowly. Right, so there we have collections of data or data types in Python. So again, hopefully that was useful. Hopefully there's value there. Please utilize the code however you like, ideally as a reference point, so that you can expand and just refresh your memory when you need to. Now this code or the GitHub repository will get updated regularly. There'll be new examples. You may find that there are other code challenges in the GitHub repository code. So by all means, have a look at them. I always provide the solutions, and I will iterate over this. So over time, I'll update this tutorial with the new challenges. So thank you very much for listening. I do hope you enjoyed this, and hopefully I'll see you in the next tutorial.